Revision of understanding elementary shapes. Right angle. So to understand this, let's see this diagram. Stand facing north and turn clockwise to east. So you have turned through right angle. That is nothing but 90 degrees. Now you further turn clockwise to south. So from north to south, that is straight angle, or two right angles, that is called 180 degrees. Right angle is 90 degrees. Straight angle is two right angles, that is 180 degrees. When you come back to north again, then this is called as one complete revolution. You are starting from north, then you go to east, south, west, and you come back again to north. This is called as one complete revolution. And how much is the angle? 90 plus 90 plus 90 plus 90, 360 degrees. So complete angle is 360 degrees. And one complete turn, one complete turn is called one revolution, and the angle formed in one revolution is complete angle, that is 360 degrees. The hand of the clock, when it moves from one position to other, it forms an angle. This is the angle formed if the hand of the clock moves from here to here. Acute angle. Acute angle is the angle when it is greater than 0 degrees and less than 90 degrees. So the angle formed here is acute angle. Obtuse angle is greater than 90 degrees and it is less than 180 degrees. So angle formed here is obtuse angle. Reflex angle is greater than 180 degrees and it is less than 360 degrees. So this is greater than 180 and lesser than 360 degrees. So this is reflex angle. Perpendicular lines. Perpendicular lines are the lines when two straight lines they intersect and angle formed between the two intersecting lines is 90 degrees, then the lines are said as perpendicular lines. What fraction of clockwise revolution does the hour hand of a clock turn through when it goes from 3 to 9? It is asking for fraction. So you know the clock is divided into 4 equal parts. You will draw one line like this. So you can see there are 4 equal parts. 1, 2, 3, 4 equal parts. So from 12 to 3 it is 1 by 4. This is 1 by 4. From 3 to 12 to 6 it is 2 by 4. So it is asking what fraction of clockwise revolution does the hour hand of a clock turns through when it goes from 3 to 9. So it is here and it should go to 3 to 9. So each is 1/4. Each fraction is 1/4. So from 3 to 9, this is 1/4 and this is also 1/4. So 1/4, 1/4 is 2/4. So how much is that fraction? 2 by 4. 2 by 4 is, if you simplify this, it is 1 by 2. You can clearly see from 3 to 9, it is half. Then from 4 to 7. 4 to 7, you have to consider this fraction. So how much is this? You can see this is 15 minutes. 15 minutes is equals to 1/4. Here also 12 to 3. Here it is 15 minutes. Here also from 12 to 4 to 7 is 15 minutes. 15 minutes is 1/4 of the fraction. It is divided into 4 equal parts. So here it is also, the answer is 1 by 4. Now 12 to 9. From 12 to 3 it is 1/4. From 3 to 6 is 1/4 and this is 1/4. So from 12 to 9, 1 by 4, 1 by 4 plus 1 by 4. How many 1 by 4? 3 times 1 by 4. This is 3 by 4 is the fraction. Now, which direction will you face if you start facing east and make 1.5 revolution clockwise? So this is clockwise revolution. 1.5 means this is 1 revolution and half means further you have to go till here. This is 1 complete revolution and half revolution is this. So where will you face? West. So the answer is west. Now you are start facing west and make 3/4 of a revolution in anti-clockwise direction. So anti-clockwise direction means you are first facing west, anti-clockwise direction is this direction. Okay, so you need to make 3/4. This is 1/4, this is 1/4, this is 1/4. So you need to make anti-clockwise. This is 1/4, 1/4, 1/4. So where did you reach? You have reached north. Now you are making south and takes one full turn south and makes one full revolution. So you are facing south, you make one full revolution. You take clockwise or anti-clockwise. You are going to reach in the same place because you are taking one complete revolution. So it is south. You will be facing south. Now find the number of right angles turned through by an hour hand of a clock when it goes from 2 to 8. Can you clearly see? From 2 to 8 it is 30 minutes. That is how many right angles? 2 right angles. Because 5 minutes is equals to 30 degrees. So here you can see 5, 10, 15, 20, 25, 30. So 30 minutes will be how much? It is 180 degrees. How did you get it? You will multiply 5 into 6 to get 30 minutes. So 30 also you will multiply to 6. So 6 into 30 is 180 degrees. Now let us take this question. 5 to 8. 5 to 8 is how much? It is 5, 10, 15 minutes. 15 minutes is 90 degrees. So how many revolutions? How many right angles here? One right angle. And here how many right angles are there? 180 is 2 right angles. And here 30 minutes is 1 right angle. And here also here it is from 10 to 7. So it is, you can see 5, 10, 15, 20, 25, 30. Till here it is 2 right angles. Then another 15 minutes is 3 right angles. So this is 3 right angles. Perpendicular bisector. If I say line L is perpendicular bisector of AB, what does it mean? It means that line L intersects AB and it makes an angle of 90 degrees with AB. So this means L is perpendicular to line segment AB. It is a perpendicular bisector means it is also going to bisect AB into 2 equal parts. If I mark this point of intersection as O, then AO is equals to OB. So perpendicular bisector makes an angle of 90 degrees and it bisects the line segment into 2 equal parts. Now let us take this question. Study the diagram. The line L, this is your line L, is perpendicular to line M. This is your line M. Is CE. CE is 2 units. equals to EG. EG is also 2 units. So because 3 to 5 is CE and 5 to 7 is CG. So first part, A part, is CE equals to EG? Answer is yes, because CE equals to 2 units and EG is also equals to 2 units. Therefore, CE is equals to EG. Now B part. Does PE bisect CG? So where is your PE? PE is here. This is your P. Does PE bisect CG? CG, can you see? This CG is in how many units? 1, 2, 3, 4. CG is 4 units. And this line is passing exactly after 2 units. And 2 units are this side. So it is perpendicular and it is bisecting this line CG. So does PE bisect CE? Answer is yes. Because here also you can see CE is equals to EG. CE is equals to EG. So this line PE bisects CG into 2 equal parts. Now let us take C question. Identify any two line segments for which PE is the perpendicular bisector. So PE has to be a perpendicular bisector. So you can take any two lines. You can take DF, it is equally divided. You can take CG, BH, AI. So you can write down any two lines. So if I write down here say BH, so here it is 3 units from 2 to 5 and 5 to 8. It is 3 units. So BH is the answer, and one more you can write AI. From 1 to 5 it is 4 units, from 5 to 9 is 4 units. So AI is also the answer. So PE is perpendicular and perpendicular bisector of BH and AI. D question. Are these true? AC is greater than FG. So first part is you need to see AC. Where how much is AC? AC is 2 units. So AC here is 2 units. How much is FG? FG is equals to 1 unit. So here you can see AC is 2 units, FG is 1 unit. So the answer is yes. AC is greater than FG. Are these true? It is true. Now let us take second part. CD. CD is how much? 1 unit. How much is GH? GH is also 1 unit. So both are 1 unit. So CD is equals to GH. Is it true? It is true because both are 1 unit each. Third part, BC is how much? 1 unit. And how much is EH? EH is 1, 2, 3 units. So EH is 3 units. So BC is less than EH. So answer is true. Classification of triangles based on sides. So based on the sides, you can classify the triangle as 3 types of triangle. First one is scalene triangle. What is a scalene triangle? In that all the 3 sides are different. Then it is called as scalene triangle. Isosceles triangle is a triangle in which 2 sides are equal. That is called isosceles triangle. Equilateral triangle has got all the 3 sides equal. So that is an equilateral triangle. Based on the angles, the classification of triangle is acute angle triangle. Acute angle triangle means all the angles are less than 90 degrees. Then it is called as acute angle triangle. Right angle triangle means one angle should be equals to 90 degrees. So this one angle is equals to 90 degrees. then it is called as right angle triangle. Last one, obtuse angle triangle. A triangle having one angle to be more than 90 degrees and less than 180 degrees, then this is called as obtuse angle triangle. So this is an obtuse angle triangle. Now let us name each of the triangles in two different ways. One way and this is the other way. So let us try to see. So first one, here you can see that all the angles are less than 90 degrees. So it is acute angled. Acute angled. And here two sides are equal. So this is isosceles. Next one, here one angle is 90 degrees. So it is called as right angled. And here all the three sides are different. So it is right angled and scalene triangle. This one angle is obtuse angle. So it is obtuse angle triangle. Obtuse angle angled, and here all the three sides are different. So obtuse angle and scalene triangle. Now let us see different types of quadrilaterals. What are quadrilaterals? A polygon having four sides is called as quadrilaterals. We have first type of quadrilateral is parallelogram. As the name suggests, both the pairs of opposite sides are parallel to each other. Okay, so opposite sides parallel, it is right, and even the opposite sides are equal. So opposite sides equal. What about all the sides? All the sides are not equal. Opposite angles, they are equal in a parallelogram. So opposite angles equal. Diagonals are not of equal length. The diagonals, they bisect each other, but they are not of equal length. So diagonals are equal? No. Are they perpendicular? No. Diagonals just bisect each other. Next is rectangle. Rectangle, opposite sides, both the pairs of opposite sides are parallel. So you can say this is a special type of parallelogram. So opposite sides parallel. And here the opposite sides are equal as well. So it is equal. All the sides are equal? No. All the sides are not equal. Opposite angles equal? Here all the angles are equals to 90 degrees. So opposite angles are equal. Diagonals in a rectangle, these are the diagonals, they are of equal length. So diagonals are equal. They are perpendicular? No. Next quadrilateral is a square. Here both the pairs of opposite sides are parallel. So this is also a special parallelogram. So both the opposite sides are parallel. Here all the sides are equal. So opposite sides are obviously equal. So opposite sides are equal. All the sides equal? Yes. Opposite angles, here all the angles, they are equals to 90 degrees. So obviously opposite angles are also equal. Here the diagonals, they are equal and they are perpendicular bisector of each other. So here the diagonals are equal and they are perpendicular. So diagonals are equal and they are perpendicular to each other. Now next is rhombus. In rhombus, both the pairs of opposite sides are parallel. So it is a special parallelogram. So opposite sides parallel, correct. Opposite sides, here all the sides are equal. So obviously opposite sides are also equal. All the sides equal? Yes. Here opposite angles are equal in a rhombus. So opposite angles are equal. Diagonals are equal? No, the diagonals are not equal, but they are perpendicular bisector of each other. So diagonals are equal? No, they are perpendicular to each other? Yes. Now this is a trapezium. It's a special quadrilateral. Here only one pair of opposite sides are parallel. Opposite sides parallel? No, only one pair is parallel. Opposite sides equal? No. Opposite angles equal? No. Here these are the diagonals. The diagonals, are they equal? No. Diagonals are perpendicular bisector. Opposite angles equal? No. Diagonals are equal? No. Diagonals are perpendicular bisector? No. Here only one pair of opposite sides are parallel. Polygons. Polygons are simple closed curve made up of entirely of line segments. So the smallest polygon is triangle having three sides. So this is a triangle. Next is quadrilateral having four sides. Then pentagon having five sides. Hexagon, six-sided polygon. Heptagon, seven-sided polygon. Octagon, eight-sided polygon. 3D shapes or three-dimensional shapes. Three-dimensional shapes have flat faces made up of polygons. It can be triangle, rectangle, anything. So the first 3D shape is cuboid. Here each face is a rectangle. So how many faces are there? 1, 2, 3, 4, 5, 6. So there are 6 faces. How many edges? Faces are the flat surfaces. So, and the flat surfaces or the faces, they meet along the edges. Two faces, they meet along the edges. So, how many edges are there? 1, 2, 3, 4. 4 behind, 5, 6, 7, 8. 4 connecting, 9, 10, 11, 12. So, 12 edges. How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Now here, how many flat surfaces are there or the faces? Same. Front and behind 2, side 2, top and bottom 2. So, 6 faces. Edges, same, 12. Vertices, 8. Cube is a special cuboid. Here, each face is a square and square is a special rectangle. Triangular pyramid. Triangular pyramid has the base as a triangle. So how many faces it has got? One base as the triangle and the three triangles are like this. So there are totally 4 faces. How many edges are there? 3 at the bottom. 1, 2, 3, 4, 5, 6. 6 edges are there. And how many vertices? 1, 2, 3, 4 vertices. Square pyramid has square at the base. So how many faces? 1 as the base and 4 connecting triangles. So there are 5 faces. How many edges? 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. How many vertices? 1, 2, 3, 4 and 5. 5 vertices. Triangular prism. Here the top and the bottom, they both are triangles. So it is a triangular prism. How many faces are there? 2 triangles and 3 connecting faces, these 2 triangles. So 5 faces. How many edges are there? 3 in front, 3 behind, 6 and 3 connecting. So 9. How many vertices? 3 in front, 3 behind. So 6. So cylinder, cone and sphere, they do not have any straight edges, as here the flat surfaces, they are meeting up at straight edges. Cylinder, cone and sphere, they do not have any straight edges. Here the surfaces are flat, rectangles, square, triangles, like that. But here the surface is curved. So cylinder, cone and sphere, they have circular edges. Cone has one vertex. Cylinder does not have any vertex Sphere also does not have any vertex. Give reasons for the following. A square can be thought as a special rectangle because when each side of rectangle becomes equal, then it becomes a square. That's why we say a square can be thought as a special rectangle. A rectangle can be thought as a special parallelogram. So when opposite sides here in a parallelogram, the opposite sides are equal, and in a rectangle also opposite sides are equal. So a parallelogram having each angle equals to 90 degrees, then it becomes a rectangle. That's why we say a rectangle can be thought as a special parallelogram. A square can be thought as a special rhombus. A rhombus becomes a square when all the angles of a rhombus are equals to 90 degrees. That's why we say square can be thought as a special rhombus. What shape is your instrumental box? Cuboid. A road roller? Cylinder. A sweet laddu? Sphere. A playing dice? Cube.